Tonight, we are going to explore a telescope that was built to photograph something that cannot be seen. The European Space Agency carried it nearly 1 million miles from Earth, gave it the widest single eye humanity has ever flown into space, and pointed it straight at the dark. And in its very first set of pictures, before its real survey had even begun, it found more than 600 hidden galaxies that no one knew were there, tucked into the glow of a cluster we thought we had already mapped. What it began to reveal about the invisible scaffolding that holds the universe together was stranger and more beautiful than anyone had dared to imagine. How do you take a picture of something that gives off no light at all? Where is almost all of the universe actually hiding? If the stars and galaxies we can see add up to only a thin sliver of everything, and why did a single hour of patient looking aimed at one quiet patch of sky leave seasoned astronomers, people who have studied the heavens their whole lives, sitting in something like stunned silence, until they slowly understood that the map of everything was about to be redrawn? If you find a quiet comfort in drifting off to the strange wonders of deep space, you might gently tap the like button or follow along, so that these calm journeys can find you again on another quiet night. There is nowhere you need to be right now, and nothing you need to solve. So settle in. Find whatever position feels easiest. Let your shoulders drop, and let us begin. Let us begin where every story about the night sky begins, with the simple act of looking up. For almost the whole of human history, this was all we had: a person standing in the dark, head tilted back, eyes adjusting slowly to the faint points of light scattered across the black. Our ancestors did this. They watched the same stars we watch. They named them, told stories about them, used them to find their way across deserts and oceans. And for all those thousands of years, they believed that what they saw was more or less the universe, the bright things, the points of light, the soft band of the Milky Way arcing overhead like spilled milk on a dark floor. And it was beautiful to them, as it is beautiful to us. On a truly dark night, far from any town, the sky is not the thin scatter of stars most of us know now from beneath the glow of city lights. It is crowded, luminous, almost overwhelming. Thousands upon thousands of stars layered into a soft silver haze. The whole arch of the galaxy laid bare overhead. People lived their entire lives beneath that sky. They fell asleep under it, much as you are settling towards sleep now. They read the seasons in it, and the time of night, and they built their stories into its patterns, drawing hunters and bears and rivers and kings across the dark. The sky was the first book, the first clock, the first map, and for most of human history, it was read with nothing more than the naked eye and a patient heart. It was a reasonable belief. When you look up, the universe announces itself in light. Stars shine, planets glow. The moon pours its borrowed sunlight down across the world. Light is how the cosmos speaks to us. It is the only messenger that crosses those vast distances and arrives at our eyes. So it made sense, for the longest time, to assume that the light was the thing, that to map the heavens, you simply had to map the brightness. But here is the quiet truth that this story turns on, and it is worth letting it settle in your mind slowly. Almost everything that exists gives off no light at all. The glowing stars, the shining galaxies, the great bright clusters that make the night beautiful. All of that visible material, every atom of it that we can see, adds up to only about 5% of the universe. 5 parts in 100. The rest, the other 95%, is dark. Not dark in the sense of empty, dark in the sense of unseen, present, heavy, shaping everything, and yet completely invisible to the eye. Take a slow breath and just hold that thought for a moment. The night sky, as gorgeous as it is, as full as it looks, is showing you only the thinnest skin of what is really out there. It is like standing at the edge of a dark ocean at night and seeing only the white tips of the waves catching the starlight. The waves are real, but the ocean beneath them, the deep, the immense weight of water that you cannot see, that is where almost all of it actually is. And the scale of that hidden ocean is almost impossible to hold in the mind, so let us not even try to grasp it all at once. Let us just walk toward it gently. The light you see from a distant star did not arrive in an instant. It traveled. Light is the fastest thing there is, crossing the gap from the Earth to the Moon in little more than a single second. And yet the universe is so vast that even light, at its impossible speed, takes years and millions of years and billions of years to cross it. Astronomers measure those great distances in light years, and a light year is simply the distance that light travels in 1 year, a span so large that a single light year stretches for nearly 6 trillion miles. So when we say a galaxy lies 10 billion light years away, we are saying that its light has been traveling toward us for 10 billion years, setting out long before the sun and the earth had even formed, long before there was anyone here to one day catch it. To look out into deep space is, quite literally, to look backward in time. Every image of the far away is also an image of the long ago. The telescope in this story is not only a kind of eye, it is a kind of memory, gathering the oldest light in the universe and holding it gently up to the present. And against all that depth and age, we are very new and very small. The Earth has been turning for about 4.5 billion years. Living things have crawled and swum and flown across it for a good part of that time. But human beings, people like us, with our questions and our wondering eyes, have been here for only a few 100,000 years, a thin sliver right at the very end of that long story. And the science of truly mapping the heavens, of measuring the universe rather than simply admiring it, is younger still, barely 100 years old. We are latecomers to a very old and very large house, tiptoeing in quietly, turning on one small light at a time, trying to make out the shape of the rooms. There is no need to feel lost in that. There is something restful in being small in a vast and ancient place. the way a child can feel perfectly safe and sleepy in a big dark house, knowing the walls are far away and the night is wide and there is nothing at all that needs doing. For most of human history, we had no way to know this. We could only count the light. But over the last 100 years or so, a handful of patient people began to notice that the light was not adding up. That the bright things were moving in ways the bright things alone could not explain. That something unseen was pulling the strings. And the slow unraveling of that mystery is what eventually led, more than a decade ago, to the decision to build a very particular kind of telescope and to send it nearly 1 million miles from home to do something no telescope had ever quite done before: to photograph the dark. But before we get to the telescope, we have to sit for a while with the mystery itself, because the mystery is the reason the telescope exists at all. And the mystery has a wonderfully strange name. Scientists call it dark matter, and alongside it, an even stranger thing they call dark energy. Two names for two great unknowns. Together, they make up almost the entire universe, and we still cannot say for certain what either of them truly is. Let us start with dark matter, because it is the older puzzle, and in some ways the gentler one to understand. Imagine a great swirling galaxy, a vast wheel of stars turning slowly in space. Our own Milky Way is one of these. So is the beautiful spiral called Andromeda, our nearest large neighbor. When you picture a galaxy turning, you might imagine it spins a little like a record on a turntable, or like the solar system in miniature, with the inner parts whirling quickly and the outer parts drifting along more slowly. The way the planets far from the sun move far more lazily than the planets close in. That is what the math of gravity predicts. The pull of gravity weakens with distance, so the stars near the bright, crowded center of a galaxy, where most of the visible mass is gathered, should orbit quickly, and the lonely stars way out at the faint edges, far from all that mass, should orbit slowly. That is what gravity, as we understand it, demands. That is what should happen if the visible stars are all there is. But that is not what happens, and the discovery that it does not happen is one of the quietest, most patient stories in all of science. The first hint came in the 1930s, from a brilliant and famously prickly astronomer named Fritz Zwicky. He was studying a great swarm of galaxies called the Coma Cluster, far out in the deep field of space. He measured how fast the galaxies in that swarm were moving, racing around one another, and then he added up all the visible matter, all the glowing material that should be supplying the gravity to hold the swarm together. And the numbers did not even come close. The galaxies were moving so fast that the visible matter could never hold them. By every law of gravity we trusted, that cluster should have flown apart long ago, scattering its galaxies into the dark, and yet there it was, still bound, still holding together, as if some enormous unseen weight were quietly gripping it from within. Zwicky gave that missing weight a name. He called it, in his native German, the dark matter, the unseen mass. And then, for the most part, the world of science set the idea gently aside. It was too strange. It was easier to assume he had made some error in his measurements, that the puzzle would dissolve once someone looked again more carefully. The idea of an invisible substance filling the universe was simply too much to swallow. So for nearly 40 years, dark matter waited in the margins, an 80-year-old mystery in the making, mostly ignored, an uncomfortable footnote that polite astronomers preferred not to dwell on. And this is where a person enters the story. Because every great scientific mystery has somewhere behind it a human being patient enough to keep looking when others have looked away. Her name was Vera Rubin. Vera Rubin was an American astronomer, born in the 1920s, who fell in love with the night sky as a young girl watching the stars wheel past her bedroom window. She wanted, more than anything, to spend her life studying them. But she came of age in a time when that path was not made easy for a woman. Doors that opened for others stayed closed for her. She was, at various points, told that certain observatories were not really meant for women to use. She was discouraged, doubted, quietly pushed toward the edges of her own field. Much like those faint stars at the edges of a galaxy, far from the bright, crowded center where the attention gathered. She kept going anyway. She was not loud about it. She simply kept doing the work, night after night, with a quiet stubbornness that is its own kind of courage. And, in the 1960s and 70s, working alongside an instrument builder named Kent Ford, she chose a problem that seemed almost too ordinary to bother with. She decided to measure, very carefully, how fast the stars at the outer edges of spiral galaxies were actually moving, beginning with Andromeda, that great neighboring spiral. She gathered her measurements slowly, painstakingly, one faint smear of starlight at a time. And what she found broke the expected picture completely. The stars at the far edges of the galaxies were not moving slowly. As gravity and the visible mass demanded, they were racing around just as fast as the stars near the center. The outer parts of these enormous wheels of stars were turning at speeds that, by all the rules, should have flung them off into space long ago. It was as if the galaxies were spinning far too fast to hold themselves together with the matter we could see. There were only two ways to explain it. Either our understanding of gravity itself was somehow wrong, or there was a vast amount of unseen mass out there, far more than all the glowing stars combined, wrapped around each galaxy like an invisible cocoon, holding everything in place with its quiet gravity. An enormous halo of something we could not see. Vera Rubin had, without setting out to, gathered the strongest evidence yet for the very thing Fritz Zwicky had glimpsed decades earlier, and the world had brushed aside. Galaxy after galaxy after galaxy told the same story. The pattern was undeniable, and slowly, measurement by measurement, the scientific world came around. The dark matter was real. It was not a mistake. It seemed, most of everything. She did not do it for fame. She did it for the love of looking, for the deep satisfaction of finally understanding something true about the sky she had adored since childhood. And though she was honored in her later years and inspired generations of young scientists, especially young women, to follow her into the dark, The universe gave her its own quiet vindication. The faint outer stars she had spent her life measuring turned out to be pointing at the single greatest hidden ingredient of the cosmos. The patient woman at the edge had found the thing the whole field had missed. It is worth pausing on her quiet example for a moment, because it sits very close to the heart of this whole story. She was not chasing a revolution. She simply wanted to know the truth about something she loved, and she was willing to gather it slowly, one careful measurement at a time. Even when the world was not paying attention, even when the world had already decided in advance that the answer was known, that willingness to keep looking, gently and without hurry, at the very thing everyone else had passed over, is the same willingness that would one day build the telescope at the center of this story. Science, at its best, is not loud. It is patient. It is a kind of long, careful tenderness toward the truth. So now we know, or rather, we strongly suspect, that the universe is mostly invisible. There is the ordinary matter, the 5%, the stars and planets and gas and you and me and everything we have ever touched. Then there is the dark matter, several times more abundant, an unseen substance that does not shine, does not reflect, does not glow, and yet has gravity. Real gravity, the same gravity that holds you in your bed right now. It clumps together in great invisible structures and lets the visible galaxies gather along it like dew along a spider web you cannot see until the morning light catches it. And here is a gentle, almost dreamlike thought to rest on for a moment. This dark matter does not stay politely out in deep space. If the picture we have is right, then it is here too, all around us, drifting through the very room where you lie, passing through the walls and the bed, and your own quiet body without a sound, without a touch, without the slightest sensation, because it barely interacts with ordinary matter at all. Vast numbers of these unseen particles may be slipping through you in this very moment, gentle and silent as moonlight, having traveled from the far reaches of the galaxy to pass through this one small room on their endless way. You are bathed in the invisible. You always have been. There is nothing at all to fear in it. It is simply the quiet substance of the universe going about its ancient business, holding the great wheels of the galaxies in their slow and patient turning, and asking nothing whatsoever of you. And then, strangest of all, there is the dark energy, which is a different beast entirely, and the larger share of the whole. Dark matter pulls things together. Dark energy seems to push everything apart. In the late 1990s, astronomers discovered something that genuinely frightened them. The universe is not just expanding, growing larger as the galaxies drift away from one another, the way most had assumed since the days of Edwin Hubble. It is expanding faster and faster as time goes on. Something is pressing on the very fabric of space, stretching it, accelerating the great drift outward, pushing the galaxies apart at an ever-quickening pace. The way this was first discovered is a small wonder in itself. Teams of astronomers were watching a particular kind of exploding star. a supernova that always flares with very nearly the same true brightness, so reliably that its apparent dimness can be used to measure how far away it sits. Like a candle of known strength glimpsed across a wide, dark field. They fully expected to find that the expansion of the universe was slowly easing, gently slowing down over the ages, as the gravity of all that matter, seen and unseen, quietly tugged everything back toward itself. Instead, they found the opposite. The most distant explosions were fainter, and therefore farther away than they should have been. The expansion was not slowing at all. It was speeding up. The result was so unexpected that the scientists who found it spent a long time searching for their own mistake before they finally, reluctantly, accepted what the light was telling them. We named that something dark energy, and naming it is very nearly all we have managed to do. We do not know what it is. We only know it is winning, and that in the deep future, it may carry every distant galaxy away over the horizon of the visible, leaving the sky emptier and emptier across unimaginable spans of time. This is the mystery. Take a moment to feel the size of it. Almost everything that exists is something we cannot see and do not understand. The bright, beautiful, familiar universe of stars is the small exception, not the rule. We are like people who have spent their whole lives studying the foam on the top of the waves and have only just begun to suspect the depth of the ocean underneath. So the question becomes a very simple one, and a very hard one. If dark matter gives off no light, if it cannot be seen by any telescope, then how on Earth, or rather how far above the Earth, could you ever hope to map it? How do you make a picture of something invisible? And the answer is the quiet genius at the heart of this whole story. You cannot photograph dark matter directly, but you can photograph what it does. You can photograph its shadow, written in light. Here is the gentle idea, and it comes from Albert Einstein, more than 100 years ago. Einstein realized that gravity does not just pull on objects, it bends the path of light itself. Anything with mass, anything heavy enough, warps the space around it, and light passing nearby has to follow that warp, curving as it travels. The way a marble rolling across a stretched rubber sheet would curve as it passes near a heavy ball resting in the middle. Mass bends space, and light follows the bend. Now imagine a vast clump of dark matter sitting somewhere far out in space, invisible, giving off no light of its own, and far behind it, much farther away, sits a distant galaxy, shining. The light from that distant galaxy travels toward us across billions of years, and on its way it passes through the warped space around the invisible clump. And so the light bends. The image of the distant galaxy gets gently stretched, smeared, curved into a faint arc or a subtle distortion, as if you were looking at it through the bottom of an old wavy glass or through the surface of a slow stream. Astronomers call this gravitational lensing, and it is exactly what it sounds like. The dark matter acts like a great invisible lens floating in space, bending the light of everything behind it. We cannot see the lens, but we can see what the lens does to the light. We can see the stretching. And if you measure that stretching very, very carefully across millions and millions of distant galaxies, all gently warped by the unseen mass between them and us, you can work backward. You can map where the invisible mass must be by reading the distortion it leaves in the light. You can draw a picture of the dark by tracing its fingerprints in the bright. You have seen a smaller version of this very trick yourself. On a hot summer day, when the air above a sun-warmed road begins to shimmer, and the things seen through it waver and bend, that hot air is acting as a lens, distorting the light passing through it. And from the wavering alone, you can tell that something is there, even though the warm air itself is perfectly clear. Gravitational lensing is that same idea, written across the entire sky. The dark matter is the clear thing you cannot see. The distant galaxies are the view beyond it. And the gentle wavering of those galaxies, the faint stretching of their shapes, is the only proof that the lens is there at all. The catch is that, for any single galaxy, the bending is so slight that you could never be certain of it. The distortion is whisper faint. So the only way to read it is to measure not one galaxy, but millions upon millions of them, and to look for the faint shared pattern in how they are all gently stretched together, the way you might never notice a single blade of grass leaning in the wind, but could easily see the whole field bend at once. That is why the telescope had to be so wide and so patient and had to gather so very many galaxies. The dark reveals itself only in the crowd. That is the secret. That is the whole improbable, beautiful trick. To map the invisible, you photograph the visible with almost unimaginable precision, and you read the dark matter in the subtle bending of the light. But to do that, you need a telescope unlike any that came before. You need an eye that can see an enormous swath of sky all at once, capturing millions upon millions of galaxies in a single sweep, and yet sharp enough to measure the faint, delicate stretching of each tiny smudge of light with extraordinary care. You need width and depth and sharpness, all at the same time, in one instrument, far above the blur of our own atmosphere. For a very long time, no such telescope existed. The great telescopes of the world were each good at one thing. Some could see very deep, staring at a tiny patch of sky for days, to drink in the faintest light from the most distant galaxies, the way the James Webb Space Telescope does, with its golden mirror and its incredible reach into the early universe. But those deep starers see only a keyhole of sky at a time. To map the whole cosmos that way would take longer than a human lifetime, far longer. Other telescopes could sweep wide, surveying broad fields of stars, but they sat on the ground, beneath the shimmering blanket of our atmosphere, which smears and softens everything, and they could not see faint enough or sharp enough to read the gentle distortions that dark matter leaves behind. What the mystery demanded was something new, and so, a little more than a decade ago, the European Space Agency made a decision. They would build a telescope designed from the very beginning for this one extraordinary purpose: to survey a vast portion of the entire sky, to capture billions of galaxies, and to measure the shape of each one precisely enough to read the shadow of the dark. They chose the mission around the year 2011, and they named it Euclid, after the ancient Greek mathematician who first set down the rules of geometry, the study of shapes in space, more than 2,000 years ago. It was a fitting name. This was, in the end, a mission about the geometry of everything, about the true shape of the universe. And then the scientists waited. They waited through years of design, years of building, years of testing every delicate part. The mission that had been chosen around 2011 would not actually fly until the summer of 2023. More than a decade of patient work, more than a decade of careful hands assembling mirrors and detectors and the cold, quiet electronics that would have to function flawlessly a million miles from any chance of repair. A whole generation of young researchers grew up inside this project, came into it as students, and left as seasoned scientists, all of them waiting for the day the telescope would finally open its eye. These were the images, in a very real sense, that scientists had been waiting many long years for. The waiting itself was part of the story. Let us slow down here and sit with that patience for a while, because there is something deeply soothing in it. We live in a world that rushes. We are used to things arriving the moment we ask for them. But the great work of understanding the universe does not move at that pace. It moves at the pace of careful hands and quiet years. People devoted decades of their lives to a single telescope, knowing they might be old or gone before its full map was ever finished. They did it anyway, because the question was worth it. Because mapping the invisible architecture of the cosmos was worth a lifetime of patience. There is a kind of peace in that, in work that outlasts the worker, in a question handed gently from one generation to the next. The telescope itself is a marvel of restraint and precision. It is not enormous, as space telescopes go. Its main mirror is a little under 4 feet across, modest compared to the giant golden mirror of the James Webb. But Euclid was never built to stare deepest. It was built to see widest while staying sharp. And that is a far rarer gift. Its great trick is its field of view, the size of the patch of sky it can capture in a single shot. Euclid takes in an area of sky larger than 2 full moons laid side by side, all at once, in exquisite detail. No telescope, before it had ever combined that width of view with that sharpness and that sensitivity. In a single observation, it can gather high-quality light from billions of galaxies, some of them so far away that their light has been traveling toward us for 10 billion years, beginning its journey before the Earth or the Sun even existed. To give you a sense of how much more this telescope can see, compared to the great surveys done from the ground, beneath our blurring atmosphere, Euclid sees with around 4 times the sharpness and roughly 15 times the sensitivity in the gentle near-infrared light, the warm light just beyond what our eyes can perceive. In a single look, it can pick out objects hundreds of times fainter than another famous space telescope. The star-mapping mission called Gaia could detect in the same glance. It captures the grand sweep of enormous cosmic structures and, in the very same image, the fine details of individual galaxies. That is the thing that made the scientists giddy when the first pictures came back. One image, holding many scales at once, the vast and the intimate, side by side, in perfect focus. Euclid does this with two instruments working together, two ways of seeing. The first is a camera that captures sharp images in visible light, the ordinary light our eyes know, and its job is to measure the precise shapes and positions of galaxies, so that those subtle gravitational distortions, the fingerprints of dark matter, can be read with great care. The second instrument is gentler and stranger. It is a near-infrared spectrometer, which is a careful way of saying it spreads the warm, invisible light from each galaxy out into its colors, the way a prism spreads sunlight into a rainbow, and reads those colors to measure something called the redshift. Redshift is a beautiful and simple idea once you let it settle. As the universe expands, distant galaxies are carried away from us, and as their light travels across that growing space, the light itself gets stretched, its color shifted toward the red end of the rainbow. The farther away a galaxy is, the more its light has been stretched, the redder it appears. So by measuring just how red a galaxy's light has become, you can work out how far away it is and place it in its proper position in depth. This is how Euclid turns a flat picture into something with depth. How it builds, galaxy by galaxy, a true map of the universe in 3 dimensions, with near and far sorted out, the largest and most detailed such map ever attempted. It will, over its full mission, chart the positions of many billions of galaxies across a vast region of the sky. And from that great 3-dimensional census, it will read the hidden distribution of dark matter and trace the slow, accelerating push of dark energy across cosmic time. It helps to picture what that map will actually be like, because it is unlike any map you have ever held. Most maps are flat, a picture of a surface seen from above. But Euclid's map has depth. It is more like a vast 3-dimensional model of the cosmos, with every galaxy set in its true place, the near ones close and the far ones deep, so that scientists can move through it and see how the galaxies are arranged not only across the sky, but back through space and back through time, layer upon layer. The recent and the ancient sorted gently into their proper distances, and woven invisibly through all of it, red from the bending of the light, will be the hidden web of dark matter, the unseen scaffolding along which everything visible has gathered. It will be, when it is finished, the closest thing we have ever made to a portrait of the universe entire, both the bright and the dark together, the largest map ever drawn by the small and curious creatures of one small world. All of that capability did not come cheaply. Of course. The European Space Agency spent something on the order of 1.4 billion euros, which is close to $1.5 billion, on the design, the construction, the launch, and the operation of Euclid. It is an enormous sum, and yet, when you weigh it against the question, it is trying to answer the true shape and fate of the entire universe. It begins to feel almost modest, $1.5 billion, spread across decades of work, to map the invisible 95% of everything, set beside the cost of so many things our world spends its treasure on. It is a small price for a glimpse at the architecture of reality. And so, after more than a decade of waiting, the day finally came. On the 1st of July, in the year 2023, Euclid sat atop a rocket at Cape Canaveral, in Florida, under a wide, bright sky. The countdown ran down, the engines lit, and the telescope that had been imagined more than a decade earlier rose up off the Earth on a pillar of fire and climbed away into the blue, carrying with it the patient hopes of thousands of people who had given years of their lives to this single moment. For a few minutes, the world could only watch and wait, as it always must at a launch. While the rocket climbed and the spent stages fell away, and the small, precious cargo at its tip was carried up out of the air and into the dark. And then came the word that it was safe, that it was on its way, that the telescope so many had waited so long for was finally, truly flying, somewhere in a quiet control room. You can be sure there were people who had to sit down, and some who quietly wept, and some who simply closed their eyes for a moment in relief. The waiting of more than a decade had become, in the space of a single morning, a thing in flight. Its destination was not orbit around the Earth, the way most satellites circle close above us. Euclid was headed somewhere far stranger and far more peaceful. It was bound for a special, almost magical point in space, nearly 1,000,000 miles from Earth, on the side of our planet that faces away from the Sun. Scientists call it the second Lagrange point, and it is one of a handful of quiet balance points in the gravitational tug-of-war between the Earth and the Sun. Places where the poles combine just so, allowing a spacecraft to hold its position and travel along with the Earth as we both circle the Sun together, like two friends walking side by side, keeping pace without ever drifting apart. There is something quietly beautiful about that idea. A balance point hidden in the sky where the great competing poles of two enormous bodies cancel into stillness, leaving a small, calm place where a delicate machine can simply rest and ride along. The universe is mostly motion, mostly falling and turning and rushing onward. And yet here and there it offers these few gentle harbors of balance. And we have learned how to find them, and to leave our most precious instruments there, floating quietly in the calm. It took Euclid about a month to coast out to that distant balance point, gliding silently across the Gulf, growing colder and quieter as it went. Picture that long, slow coast through the dark. If it helps you drift toward sleep, no engine roaring, no sense of speed at all, just a small craft falling silently outward. The bright blue earth shrinking behind it day after day until it was only a pale dot. The sun growing a little more distant. The deep cold of space settling in gently around the instruments. For a full month it glided, untouched and untouchable, across nearly 1,000,000 miles of almost perfect emptiness, carrying its single careful eye toward the quiet harbor where it would do its life's work. And when it arrived, it was not alone. That same peaceful spot, nearly 1,000,000 miles out is home to a small gathering of humanity's most precious eyes on the universe. The great James Webb Space Telescope is there, drinking in the faint light of the earliest galaxies. The star-mapping telescope called Gaia is there, charting the precise positions of more than 1 billion stars in our own galaxy. And now Euclid joined them. 3 quiet instruments holding their stations in the cold and the dark, each keeping the sun, the earth, and the moon behind it at all times, so that nothing bright would ever interfere with the gentle work of looking outward into the deep. That location is chosen with great care, and the reasoning behind it is lovely in its simplicity. Out there, with the sun and the earth and the moon all kept to one side and behind, the telescope can stare into the darkness undisturbed, with nothing nearby to flood its delicate sensors with stray light. And yet it is close enough to home that messages can still pass back and forth without too long a delay. So the spacecraft and its keepers on the ground can stay in steady, patient conversation. It is, in a sense, the perfect reading chair for the universe. Far enough from the noise and the glare to think clearly, close enough to still hear when home calls. So picture it now, if you like, as you lie there in the quiet. A small, cold, careful machine, nearly 1 million miles away, holding perfectly still in the eternal night. Its single wide eye turned outward toward the deep. It has traveled across that great gulf. It has settled into its balance point beside its silent companions. The years of waiting are nearly over. And now it must simply open its eye and begin to gather light that, in many cases, set out on its journey toward us long before there was anyone here to receive it. The first images did not come all at once. There were months of careful preparation, of checking and adjusting, of making sure every mirror was aligned and every detector was reading true. The scientists watched and waited a little longer, as they had already waited for so long. And then, in October of the year 2024, Euclid began to send back the first real pieces of its great map, the first light, the first glimpses of what it could truly do. Let us slow our breathing here and approach that moment gently, the way the scientists themselves must have. Imagine the room. Imagine people who have spent 10, 15, 20 years on this single dream, gathered around their screens, waiting for the data to arrive across 1 million miles of empty space. The images come in slowly, line by line, building down the screen the way an old picture used to develop. Brightness gathering out of the dark. And then the full frame resolves, and there is a long, soft silence in the room. The kind of silence that means something has gone right beyond all hoping. Because the pictures were not just good, they were extraordinary. One of the scientists, trying to put words to it afterward, said that they had never seen astronomical images quite like these before, that they held so much detail, that they were sharper and more beautiful than anyone had dared to hope for, revealing features never glimpsed before, even in well-studied corners of the nearby universe. These were people who looked at deep space for a living, who had grown used to wonder, and even they were undone by it a little. The telescope they had waited so long for had opened its eye, and the universe had answered with a richness that exceeded every expectation. Try to feel for just a moment what that must have been like, to give the better part of your working life to a single instrument, to a single question, never quite certain it would work, and then to sit in a dim, quiet room and watch the answer arrive, line by line, more beautiful than you had let yourself hope. There would have been no shouting. Most likely, the deepest joys rarely make much noise. Just a long-held breath, finally let go, and a few people leaning slowly toward their screens in the soft glow, looking at something no one had ever seen before, and knowing, at last, that all the years had been worth it. So let us take the slow tour now. Let us walk through those first images one at a time, gently, the way you might wander through a quiet gallery late at night, with no one else around, with all the time in the world. There is no rush. There is nothing to remember. Just let each one wash over you. The first thing they show us is the beginning of the map itself. In the early spring of 2024, over a stretch of about 2 weeks, between late March and early April, Euclid swept its gaze across a region of the southern sky and took 260 separate pictures, then stitched them together into a single seamless mosaic. That one mosaic alone covers an area of sky around 500 times the size of the full moon as we see it from Earth. Hold that in your mind for a moment. The full moon looks large to us, large enough to light a path on a clear night. Now imagine 500 of them laid out across the dark, and every bit of that vast field captured in fine detail, holding within it many millions of stars and galaxies, each a faint point or smudge of ancient light. And here is the part worth letting sink in slowly. The part that gives a sense of the scale of what is to come. That enormous mosaic, that field of millions of stars and galaxies, larger than 500 full moons, represents only about 1% of the total map Euclid was sent to make. 1 part in 100. The telescope is meant to chart roughly 1/3 of the entire sky over its mission. So everything in that first breathtaking mosaic, all those millions of distant suns and far-off galaxies, is a single thin slice. The first small page of a book that will run to hundreds of pages before it is done. The map of the cosmos that Euclid is drawing is so large that its first dazzling installment is barely a whisper of the whole. It is worth letting the patience of that sink in as well, because patience is the soft thread running through this entire story. The telescope does not race to finish. It works the way a tide works, or the way a season slowly turns, gathering its great map a little at a time, sweeping the same patient eye across patch after patch of sky, year after year, building the whole slowly out of countless careful pieces. No single night reveals very much, but the nights add up, the way grains of sand add up into a dune, the way small kindnesses add up into a life. And in the end, out of all those quiet, unremarkable observations, a portrait of the entire visible universe will slowly take shape, far larger than any one person could ever hope to take in. Because Euclid captures the big picture and the fine detail in the very same image, the scientists can move through that map like a traveler zooming in on a globe. They can pull back and see vast stretches of the universe at once, great fields scattered with galaxies. And then they can zoom inward, smoothly, into a single cluster of galaxies, and then into one galaxy within it, and then almost down to individual stars. The same picture serves both the grandest view and the most intimate one. So let us do exactly that. Let us zoom in, gently, on some of the wonders hidden inside that first map. The second thing they show us is one of the largest structures known in the entire universe, a great city of galaxies called the Perseus Cluster. It lies about 240 million light-years away from us, which means the light in this image left those galaxies 240 million years ago, long before the dinosaurs, when the most complex life on Earth was still finding its way. In this single image, Euclid captures more than 1,000 galaxies belonging to the Perseus cluster itself, each one a swirling island of billions of stars, and behind them, scattered across the deeper dark, more than 100,000 additional galaxies, fainter and farther away, stretching back across enormous gulfs of space and time. Take a slow breath and let that number rest on you. 100,000 galaxies, in the background of a single photograph, not stars. Galaxies, each one a whole Milky Way, or larger, each holding its own hundreds of billions of suns, its own quiet worlds, perhaps its own oceans and storms and skies, all of them caught together in one frame, like grains of sand on a single small stretch of beach, while the whole shoreline of the universe runs on past the edges of the picture, farther than any eye can follow. And the way those galaxies are arranged, the way they gather and cluster and string themselves together across the dark, is itself one of the great clues to the invisible. Scientists believe that dark matter, that unseen mass, does not spread itself out evenly. Instead, it seems to draw together into vast threads and filaments, an enormous hidden web stretching across the whole cosmos, like the strands of a spider web you cannot see until the light catches it. And where those invisible threads cross and tangle and gather thickest, that is where the visible galaxies collect, pulled in by the gravity of the dark, clinging to the unseen scaffolding like dew gathering along a web at dawn. If there were no dark matter at all, the thinking goes, the galaxies would be sprinkled evenly and randomly through space, like salt scattered on a table. But they are not. They gather, they cluster, they trace out a hidden structure. And by studying exactly how they gather, Euclid can begin to map the shape of the invisible web that draws them in. Inside that great Perseus cluster, Euclid found something that had been hiding in plain sight. Astronomers had long suspected, from their computer models of how galaxies form, that clusters like Perseus should contain many small, faint companion galaxies, little dwarf galaxies drifting at the edges, far dimmer than their giant neighbors, But these dwarf galaxies are so faint and so easily lost in the glare of all the brighter stars and galaxies around them that they had mostly stayed hidden, slipping past every telescope that had tried to find them. They were the faint edges again, overlooked, drowned out by the bright, crowded center, much like the outer stars Vera Rubin once chased. And in this one image, Euclid found more than 630 of them. 630 previously unknown dwarf galaxies in a single cluster, brought out of the dark for the first time. It was a quiet landslide of a discovery, because each of those little galaxies is a small, gentle gravitational marker, a place where the bending of light and the gathering of mass can be read. And so each one is another faint clue to where the dark matter lies and how it is shaped. 630 new pieces of the invisible puzzle, found in an afternoon's worth of looking. In a corner of the sky we thought we already knew. Let that settle softly. We had photographed the Perseus cluster before. We thought we had seen it. And then we looked with the right eye, and 630 hidden galaxies stepped quietly out of the glow, each one older than the Earth, each one waiting patiently across 240 million years for someone to finally notice it was there. There is a tenderness in that. When you let yourself think about it slowly, those little galaxies were there the whole time. They had been shining their faint light across hundreds of millions of years, unnoticed, unrecorded, simply existing in the dark beside their brighter neighbors. They did not need us to see them in order to be real. And yet there is something moving about the moment they were finally seen, the way there is something moving about any small overlooked thing being noticed at last. The universe is full of faint, quiet presences like that, drowned out by the bright and the loud, waiting without impatience to be found. Euclid is, in its gentle way, a finder of overlooked things, a patient eye for the dim and the easily missed. The third thing they show us takes us much closer to home, to a small and rather scruffy galaxy with a plain catalog name, a galaxy known as NGC 6822. It shines about 1.6 million light-years away, which makes it a near neighbor in cosmic terms, just beyond the edge of our own little family of galaxies. It is what astronomers call an irregular galaxy, meaning it has no graceful spiral arms, no neat shape, just a loose, glowing, slightly chaotic gathering of stars and gas, like a handful of bright sand tossed gently into the dark. This little galaxy has a quiet place in history. It was first recognized as a distant stellar system, a galaxy in its own right, far beyond the Milky Way, by the great astronomer Edwin Hubble, back in the year 1925. Hubble was the one who first showed the world that those faint smudges in the sky were not clouds within our own galaxy, but entire separate galaxies, island universes, unthinkably far away. He cracked open the true scale of the cosmos, and now, almost exactly 100 years later, Euclid has photographed that same little galaxy that helped reveal the size of the universe, but with a sharpness and a breadth Hubble could only have dreamed of, capturing the entire galaxy and its surroundings in one clear, gentle frame. The James Webb Telescope had also looked at this galaxy a few years earlier, but only through a narrow keyhole, a small slice of it at a time. Euclid took in the whole thing at once, and that wide, gentle view is exactly what makes it so valuable. Scientists study little galaxies like this one to understand how stars form, and how the very early universe behaved. Here is the reason. Told simply, stars are the great forges of the cosmos. Deep in their hot hearts, they press the lightest atoms, hydrogen and helium, together to build heavier elements, the carbon and oxygen and iron and all the rest. The very stuff that planets and people are eventually made from. But this takes time. It happens slowly, across the long lives and fiery deaths of generations of stars. So in the early universe, before many stars had lived and died, there were very few of these heavier elements around. And this scruffy little neighbor galaxy, surprisingly, still has very low levels of those heavier elements, almost as if it is a small living echo of the early universe. A place that never fully grew up, that still resembles the cosmos as it was long ago. By studying galaxies like this one, with so little heavy material in them, scientists can peer backward in a way, learning how galaxies grew and how stars came together in the universe's youth. Euclid, with its rich color information and its wide, gentle gaze, made that study far easier than it had ever been. And in the process, it revealed clusters of stars and glowing clouds of gas within the little galaxy that had never been clearly seen before. Among them were the soft pink and red clouds where new stars are being born, regions where freshly kindled stars pour out light so fierce that it makes the surrounding hydrogen gas glow, like coals warming the air above a fire. Studying those glowing nurseries helps us understand the conditions a star needs in order to be born at all. The fourth thing they show us is a thing of pure, dense beauty. A great glittering ball of stars called a globular cluster. This one carrying the catalog name NGC 6397. It sits about 7,800 light-years away, which makes it the second nearest such cluster to us in all the sky. A globular cluster is one of the loveliest objects in the heavens, an enormous swarm of hundreds of thousands of stars, all bound tightly together by their mutual gravity into a glowing sphere, densely packed at the center and thinning gently toward the edges, like a soft snowball of light hung in the dark. There is a gentle problem with studying these clusters, though, and it is the same problem we keep returning to. The brightest stars near the crowded center shine so fiercely that they drown out the smaller, dimmer stars, especially the faint, low-mass stars that drift far out in the cluster's sprawling outskirts. And yet it is precisely those faint outer stars that hold some of the deepest secrets, the clues to the long history of our own Milky Way, written in their quiet light. They are, once again, the faint things at the edges, the easily overlooked, the patient ones waiting to be noticed ones. What makes Euclid so special here is that it can hold the entire cluster in a single image. The blazing crowded center and the faint sprawling edges all at once, and still tell the dim outer stars apart from one another and from the background of the deeper sky. As one astronomer put it, no other telescope can take in a whole globular cluster like this, and at the same time pick out its faintest members way out in the thin outer regions. The Hubble telescope had once photographed the bright heart of this very cluster, but to capture the entire thing, including those vast, faint outskirts, would have cost Hubble an enormous amount of precious time. Euclid gathered the whole glittering portrait in a single hour. 1 hour of patient looking. And an object that would have taken another telescope days or weeks lay revealed in full. Beautiful, both to the scientist and to the simple, wondering eye. And there is a lovely open mystery folded into these clusters. Sometimes the stars in the universe gather themselves into these tight, glowing balls, and sometimes they spread out into grand spiral wheels, like the galaxy we ourselves live inside. And yet, for all our study, we still do not fully understand how a spiral galaxy holds its graceful shape over the long ages. Why its arms do not simply wind themselves up and blur away. We live inside one of these great spirals, and still we cannot fully explain it. The pictures Euclid is gathering, of clusters and galaxies of every kind, are meant to help us slowly answer questions like that one. Questions we have lived inside our whole lives without resolving. There is a strange comfort in that admission that we live inside a thing we do not fully understand and turn out perfectly fine all the same. We do not need to solve the galaxy in order to belong to it. We simply ride along on it. All of us. Every person who has ever lived, carried slowly around its great bright wheel once every couple of 100 million years, whether we understand it or not. The understanding can come slowly, image by image, century by century. The belonging is already complete. The fifth thing they show us is a galaxy that looks, in many ways, like a portrait of our own home. It is known sometimes as the Hidden Galaxy, and it carries the catalog name Caldwell 5. It lies about 11 million light-years away, and it has earned its nickname honestly, because it is genuinely hard to see. It sits in a crowded direction of the sky, low in the busy disk of our own Milky Way, so that, to look at it, we have to peer through a thick, foreground haze of our galaxy's own dust and gas and stars. All of it dimming and obscuring the view, like trying to see a distant house through a dirty, fogged-up window. And yet astronomers are fascinated by this hidden galaxy, precisely because it is thought to be a close look-alike of our own Milky Way, a kind of mirror held up across 11 million light-years. This matters more than you might think, because there is something almost impossible about studying the galaxy you live inside. We are stuck within our own Milky Way, embedded in its disk, and so we can only ever see it edge on from the inside, the way you can never quite see your own house from the outside while you are standing in your own living room. To understand the shape of our home, it helps enormously to study a galaxy that closely resembles it from the outside, looking in. Euclid's gentle, near-infrared eye, The part of its vision tuned to that warm light just beyond the red was able to pierce straight through the obscuring dust and haze and reveal the hidden galaxy in its full glory, in a way no telescope on the ground had ever managed. We had glimpsed it before, but never with anything close to this clarity. And here, again, is the quiet magic of this telescope, captured by one of the scientists who worked on it. The image might look, at first glance, almost ordinary, as if any telescope could make it. But that is exactly what is so remarkable. In one single picture, we can see the entire sweeping galaxy whole. And we can also zoom inward and pick out individual stars and clusters of stars within it. We can trace the long history of how its stars formed and aged across the lifetime of the galaxy, all from one gentle frame. The wide and the close, together as ever. This is the kind of image that helps scientists slowly untangle the deep connection between dust, gas, and the birth of stars on the grand scale of a whole galaxy, in a way that was simply never possible before. By studying this near mirror of our own home in such rich detail, we learn a little more about the great wheel of stars we ourselves are riding through the dark, and about the unseen dark matter that we believe is quietly holding its lovely spiral together. And now we come to the last image, and the loveliest of all, the one the scientists themselves saved for the end. Let us slow right down for this one, because it is worth lingering over. It is the famous Horsehead Nebula, a great dark cloud shaped in the eye of the imagination, like the head and arched neck of a horse rising up out of a sea of glowing gas. It has been photographed many times before by many telescopes, but never with the sharpness and the wide, gentle sweep that Euclid managed here. And once again, almost unbelievably, it captured the whole scene in a single hour. The scientists said it was like someone simply pulling over at a beautiful viewpoint on a long drive and casually snapping a photograph. Except the viewpoint was a cathedral of star birth, and the casual snapshot was the finest portrait of it ever made. The Horsehead Nebula lies about 1,375 light-years away, which makes it, by the measures of this story, practically next door. And it is the nearest large region of star formation to our own solar system. It rests just south of a star called Alnitak, the easternmost of the 3 stars that make up the belt of the constellation Orion. That great hunter striding across the winter sky, a shape that almost everyone has looked up and noticed at some point in their lives, perhaps without knowing its name. The Horsehead is part of a vast complex of gas and dust called the Orion Molecular Cloud, an enormous cold nursery where new stars and new worlds are quietly coming into being. The glowing backdrop behind the dark horse shape is hydrogen gas, lit up and made to shine by the fierce ultraviolet light pouring off a nearby bright star. And the dark horse shape itself is something else entirely, a dense, cold cloud of molecular hydrogen, so cold and so quiet that it gives off almost no light or warmth of its own, standing in silhouette against the glow behind it, like a darkened hill against a sunset sky. That contrast, the cold, dark cloud against the bright, warm glow, makes the Horsehead a perfect place to study how stars are born, because scientists can watch and compare how the process unfolds in the dark, quiet clouds and in the bright, glowing ones, side by side, in a single view. And here is the wonder that Euclid was truly hunting for in this place. Inside that swirling nebula, the scientists hope to find evidence of many previously unknown worlds the size of the giant planet Jupiter, drifting freely through the gas. Some of these are what astronomers call free-floating planets, and the name itself is a small marvel. These are worlds, real planets, that do not orbit any star at all. They wander alone through the dark between the stars, untethered, parentless, drifting through the cold on their own slow paths, perhaps cast out long ago from the systems where they were born, or perhaps formed alone in the quiet, never having had a sun to call their own. One such world had already been identified in this region, a young planet roughly 10 times the mass of mighty Jupiter, glowing with the heat of its own recent birth at a temperature of around 2,200 degrees Fahrenheit. And with Euclid's extraordinary sensitivity, its ability to catch the faintest of faint light, the scientists found many more of these lonely drifting worlds, smaller ones than had ever been catalogued in that region before. The research suggested that, in that part of the nebula, these free-floating planets are not rare oddities at all, but seem to be everywhere, numerous and common, a whole hidden population of starless worlds wandering through the glowing dark. Let that image carry you for a moment as you rest. Out there, more than 1,000 light years away, in a great cold cloud shaped like the head of a horse, there are worlds with no sun, drifting alone through the dark, each one a planet, each one silent, each one unseen, until a patient telescope 1,000,000 miles from Earth finally caught their faint, lonely glow. We are not even halfway through this story before we have already found whole worlds that no one knew existed, simply by looking carefully at the dark. Sit with that horse-shaped cloud for a moment longer, because it is one of the loveliest things in all the sky. It is enormous, far larger than our entire solar system, a slow, dark sculpture of cold gas standing against a soft curtain of glowing light. And it is not truly still, though it looks perfectly still to us, over spans of time too long for any human life to notice. It shifts and drifts and slowly comes apart, and from its cold, dense pockets, new stars and new worlds quietly condense, kindling out of the dark the way frost flowers form on a winter window, slowly, silently, with no one there to watch. And here is the gentlest part of all. Everything we are made of was once part of a cloud like that one. Every atom in your resting body, the iron in your blood, the calcium in your bones, the oxygen you are breathing slowly in and out right now, was forged inside ancient stars and scattered through great clouds of gas and gathered across billions of years into the world that became you. To look at the Horsehead is, in a very real and quiet way, to look at where we all come from And here is the thing to remember about everything we have just walked through together. The map. The great cluster with its hundreds of hidden dwarf galaxies. The scruffy little neighbor galaxy. The glittering globular cluster. The hidden mirror of our own home. The horse-shaped cloud full of lonely worlds. All of that. Every single one of those marvels came from that first 1%, from the first thin page of the map, from the opening glance of a mission that is meant to last for years and to chart roughly a third of the entire sky. After that first light, Euclid still had more than 5.5 years of its survey ahead of it. An ocean of looking still to come. Everything we have seen so far is the faintest opening note of a symphony that will play on long into the future. In the years ahead, that wide, patient eye will sweep across roughly a third of the entire sky, charting the shapes and the distances of many billions of galaxies. Far more than any one mind could ever picture. Slowly, painstakingly, it will fill in its three-dimensional map, and as it does, the hidden distribution of dark matter will emerge from the data like a landscape emerging from fog at dawn. Soft ridges and valleys and great invisible mountain ranges of unseen mass. The true terrain along which all the bright galaxies have settled. And by watching how that terrain has changed across cosmic time, how the great structures grew and gathered as the universe aged, scientists hope to read the fingerprints of dark energy too. That strange pressure slowly pushing it all apart. It is a labor of years, perhaps of decades, perhaps of more than one human lifetime. But that has never stopped the people who do this kind of work. They have always been quietly content to plant trees whose shade they will never sit in. So why does it matter? You might be lying there, drifting, and a small part of you might wonder, gently, what any of this has to do with the quiet, ordinary life of a person on Earth. And it is a fair and good question, and the answer is, in its own way, soothing. It matters because Euclid is slowly building the first true map of the invisible. For all of human history, we have known only the bright 5%. Now, by reading the gentle bending of light across billions of galaxies, we are beginning to chart the unseen 95%, the dark matter that holds the galaxies together and the dark energy that drives them apart. A three-dimensional map of where the dark matter actually lies could utterly transform our understanding of the most basic rules of reality, the fundamental laws that govern everything, from the largest cluster of galaxies down to the smallest particle. We may finally begin to learn what the dark things truly are, and in doing so, learn what kind of universe we actually live in, and how it began, and how it will end. And there is something quietly grounding in that. Rather than frightening, we are a small, young species, on a small blue world, circling an ordinary star, in the faint outskirts of one ordinary galaxy, among hundreds of billions. We have existed for only the briefest flicker of cosmic time, and yet, here we are, building delicate machines, sending them 1,000,000 miles out into the cold, and using them to gently photograph the shadow of the invisible, to read the architecture of all that is. There is a deep dignity in that, a quiet kind of courage. The same patient looking that began with our ancestors lying in the grass and naming the stars has carried us, in the end, all the way to the edges of the scene and out into the dark beyond it. And it matters, too, in a smaller and more human way. Every one of these discoveries was made by people working together, patiently, across borders and across years, pooling their knowledge and their care towards something not one of them could ever have done alone. The telescope was imagined by some and built by others, and flown by others still. And the pictures it sends home will be studied by people who are not yet born. It is a quiet reminder that the largest and most lasting things we make are almost never the work of a single pair of hands. They are handed forward, gently, like a candle passed from one person to the next, so that the flame is never lost. Let us pause here, before we begin our slow walk back towards sleep, and simply rest for a moment in the wonder of it. Think of all the patience this story is made of. The patience of Fritz Zwicky, glimpsing the dark and being doubted. The patience of Vera Rubin, measuring faint stars night after night until the truth could not be denied, and being vindicated by the very edges everyone else had ignored. The patience of the thousands of engineers and scientists who gave more than a decade of their lives to a single telescope, knowing the full map would not be finished for years still to come, perhaps not in their working lifetimes at all. The patience of the light itself, traveling for millions and billions of years across the dark to arrive, at last, at a small, cold mirror waiting 1,000,000 miles from Earth. There is a gentle lesson tucked inside all that patience, and you do not have to hold on to it. You can simply let it drift past. It is that the most important things are often the things we cannot see. That the brightest, loudest, most obvious parts of anything are usually only a thin sliver of the whole. That beneath the visible surface of the world, of a life, of a night sky, there's almost always a vast and quiet structure holding everything together, unseen, doing its patient work without ever asking to be noticed. The dark matter does not shine. It does not announce itself. It simply holds the galaxies in their slow and graceful turning, and asks for nothing in return. There is a kind of peace in being held by something you cannot see. You might let that thought stay with you as you drift, that so much of what truly matters is quiet and unseen and asks for nothing in return. The slow turning of the galaxies, the patient travel of ancient light, the gentle gravity that holds it all together without a sound. None of it needs to be watched in order to keep working. None of it needs to be understood in order to keep you safe. It simply continues, vast and calm and unhurried, the way the night itself continues all around you now, holding the whole sleeping world the way it has held every sleeping creature that has ever lived beneath it. And now, as the night deepens around you, let us gather the whole story together one last time, gently, so that you can let it all go. There is nothing here you need to remember. Let the details soften and blur. Just follow the shape of it as it drifts past, like a slow river carrying you toward sleep. It begins, as these things always do, with people looking up at the dark and believing for thousands of years that the bright stars were all there was. It begins with the slow, uncomfortable discovery that the bright things were moving in ways the bright things alone could never explain. With Fritz Zwicky, glimpsing an unseen mass in a swarm of galaxies and being set aside. With Vera Rubin, patiently measuring the faint outer stars of spiral galaxies, finding them racing far too fast, and proving, against the doubt of her time, that the universe is mostly made of something we cannot see. It grows into the great twin mystery of dark matter, which gathers the galaxies, and dark energy, which drives them apart. The two great unknowns that together make up almost everything. It moves on to a beautiful idea, that you can photograph the invisible by photographing what it does to the light, by reading the gentle bending and stretching of starlight as it passes the unseen mass. A thing called gravitational lensing, it moves to a decision, made more than a decade ago, to build a telescope for exactly that purpose, and to name it Euclid, after the ancient student of shapes. It passes through more than a decade of patient building, through the careful work of thousands of hands, and then it lifts off on the 1st of July, 2023, from a sunlit pad in Florida, and coasts for a month out to a quiet balance point nearly 1 million miles from Earth, where it settles in beside the James Webb Telescope and the Gaia Telescope. 3 silent eyes turned outward into the deep. And then, after all that waiting, in October of 2024, it opens its eye, and the universe answers. A mosaic larger than 500 full moons, holding millions of stars and galaxies, and yet only one part in 100 of the map to come. A great cluster of galaxies with 100,000 more galaxies scattered behind it, and 630 hidden dwarf galaxies stepping quietly out of the glow. A scruffy little neighbor galaxy that Edwin Hubble first recognized 100 years before, glowing with the pink clouds of newborn stars. A glittering ball of hundreds of thousands of stars, captured whole in a single hour. A hidden galaxy that mirrors our own home, revealed at last through the dust. And a great cloud shaped like the head of a horse, full of lonely worlds drifting with no sun to call their own. All of it. The faintest first note of a song that will play on for years. You have come a long way tonight. You have traveled from your own quiet room, all the way out to a cold telescope 1 million miles from Earth, and from there out across 240 million light-years to a city of galaxies, and back again. You have looked at the invisible, and at worlds with no stars, and at the gentle, patient web that holds the cosmos in its place. And now there is nothing left to do with any of it. There is nothing to remember. You can let it all drift away. Every number, every name, every distant galaxy. Like lights going soft on a far shore as a boat carries you gently out onto calm, dark water. Let your breathing slow now, all on its own. The way the tide slows as it reaches the top of the sand. There is no effort needed. Just let each breath come a little softer than the last, a little slower, like waves arriving on a quiet beach in the dark, one after another, with all the time in the world between them. Let your shoulders grow heavy. Let them sink down into whatever holds you. Let the small muscles around your eyes go soft, and your jaw loosen, and your forehead smooth itself out like still water. Feel how heavy your arms have become, and your legs sinking gently, warm and quiet, with nowhere to go and nothing to hold. The day is behind you now. Everything you carried through it, every task, every worry, everything left undone. You can set it all down here in the dark. None of it needs you right now. There is nothing to solve tonight. There is nothing to reach for. You are warm, and you are safe, and you are held. The way the galaxies are held by the gentle unseen thing that asks for nothing. Out there, 1,000,000 miles away, the telescope is still watching, patient and quiet, gathering the faint old light of galaxies that shone before the Earth was born. It does not hurry, it does not strain. It simply holds still in the dark and lets the light come to it. One soft photon at a time. You can do the same now. You do not have to reach for sleep. You can simply hold still and let it come to you, gently, on its own, the way the light comes to the waiting mirror in the deep. Let the whole vast picture grow soft and distant now, the way the lights of a far shore blur and merge into one another as the water carries you gently outward. You do not need to hold on to any of it. The galaxies will keep turning without your watching. The telescope will keep gathering its light without your help. The great hidden web will keep holding everything in its quiet place, tonight and every night, whether you are awake to think of it or fast asleep. So, you are free to let go now, free to sink down into the warmth and the dark, and to rest completely, with nothing left to carry and nowhere left to be. Breathe slow. Let the dark be soft around you. There is nothing more to see tonight, and nothing more to know. The invisible web holds the galaxies. The galaxies turn, slow and silent, across the long ages, and you are a small, warm part of all of it, resting now, exactly where you are meant to be, far out in the quiet. A horse-shaped cloud drifts among its lonely worlds, and the light keeps traveling, patient and unhurried, across the gentle dark. Rest now, sleep deeply, and let the gentle dark hold you until morning.